First. Real world. Source: ChatGPT. Real world is a relative concept, because everyone's understanding and experience of reality may be different. Here are some ideas that may help understand this concept. Objective reality. This refers to a reality that exists independent of an individual's perspective. This includes the laws of nature, the physical world, and scientific facts. Objective reality is relatively fixed and universally accepted, independent of personal opinions. Subjective reality. This refers to each person's subjective experience and interpretation of reality. Each person's perspectives, beliefs, values, and perception styles influence their understanding of reality. Therefore, even if the objective reality is the same, people's subjective experiences may still be different. Social constructionism. This view holds that reality is socially constructed by culture, social institutions, and collective beliefs. This means that people's opinions and experiences are influenced by the society around them. Psychological perspective. In psychology, people often think of reality as part of an individual's mental state, including perception, memory, and cognitive processes. These mental processes can be affected by a variety of factors, including sensory limitations, memory distortions, and cognitive biases. In general, the real world includes not only objective facts, but also subjective interpretations and experiences of individuals and society. People's opinions and perceptions may vary based on a variety of factors, making the definition of true a relative term. Source: Science Online. Has science seen the real world? In January 1665, Samuel Pepys had dinner with the president of the Royal Society after spending an afternoon with prostitutes. On the way home, he went to the bookstore and ordered Robert Hooke's latest book on microscopy. A few weeks later, Pepys took the book home and spent most of the night reading illustrations of microscopic objects. Later, he wrote in his diary, "This is the most original book I have ever seen in my life." Pepys originally had a microscope, but had never seen images like this. He and other readers were deeply shocked by the detailed images described by Hooke. Hooke modified commercially available microscopes to show insects, minerals, and plants. Feather details. For the first time, people in the 17th century had the opportunity to observe the appearance of small and familiar things in daily life, such as fleas, mold on cheese, crystal particles in urine, lice, and nettle stings. In the text that accompanies the image, Hooke described to readers, "The louse looks so proud and high, as if he is afraid that he cannot defeat the stronger opponent, but he is like a fearless king." Hooke originally published his observations and reports at the weekly meetings of the Royal Society in London, which was just established at the time. Members encouraged him to publish his depictions and publicize their new methods of studying the world to the outside world. At that time, the Society had Francis Bacon as its titular leader. In 1621, Bacon lost his position as Chancellor due to corruption charges. His political career came to an end, and he was able to devote himself wholeheartedly to the field of philosophy. He opposed Aristotle's theoretical basis and advocated that observation and experiment are the best ways to understand the world created by God. Bacon emphasized in his writings that under the interpretation of the Bible, humans are fallen creatures with limited vision, and what they see in front of them is blinded by imagination. To overcome the inherent weaknesses of human beings, Hooke invented tools that enhance sensory abilities such as hearing, smell, and vision. Illustrations of small objects also aims to prove that the beauty of all things created by God can only be appreciated through transcendent and objective observation. Hooke believed that researchers who observe through a microscope only need to draw natural features directly on paper, examine and record what they see with a sincere hand and a faithful eye, in order to support Bacon's view of human defects in the Bible. According to the theory's view, the first edition of Illustrated Micro-Objects showed defects in man-made objects. Under the microscope, the sharpened razor was full of chips, the needle tip was blunt, and even the blurred outline of the period could be clearly seen. But in fact, Hooke discovered that sincere hands and faithful eyes are not enough to capture the natural appearance, because microscopic images are often vague and still rely on personal expertise and personal interpretation. Hooke mentioned, under certain lights, a fly's eye looks like a lattice window, full of countless small holes. Under the sun, it looks like a surface covered with gold spikes. From another angle, it looks like a surface covered with pyramids. Sometimes it looks like a surface covered with pyramids. Like a cone, an observer needs tools but also the skills to judge what the right answer is. Hooke realized that when he tried to recreate the image on paper, other problems arose. What the readers of illustrated micro-objects see are not the original specimens. They have gone through two layers of media, Hooke and the artist. Hooke also accused the artist of making mistakes in the finished product. Moreover, Hooke's paintings are all in black and white, and most of them are scattered across the entire paper, unlike the original specimens. What he saw in the eyepiece field of view was the colorful microscopic world. In theory, as technology advances, Hooke and the readers of his works may be able to see things more clearly. But the history from Hooke to modern microscopists is not a smooth one. Researchers in the 18th century after Hooke were obsessed with perfect pictures, so they often did not record natural specimens faithfully, but used imagination to modify and beautify the facts they observed. For example, an ant was found to be missing a leg or head under the microscope. The head is underdeveloped, but the painter will draw the appearance of an ideal ant based on the images of ants he has seen in the past, as if to capture the essence of the ant. This attitude was similar to the mentality of anatomists at the time. When anatomists drew the female skeleton, they drew the pelvis wider based on the function of pregnancy, and the skull in the male skeleton diagram was also larger. Around the mid-19th century, the trend in biological research turned towards letting nature show its original appearance. Scientists began to insist on faithfully recording all defects when observing individual specimens. With the vastly improved accuracy of new microscopes, scientists hope to suppress subjective judgment. However, just like the situation Hooke encountered 200 years ago, researchers cannot completely eliminate human factors. On the contrary, as the equipment becomes more and more complex, the traces of scientists' chisels are getting deeper. Because the lens is more powerful, the part that can be seen at each time is more limited, which means that more professional skills are needed to distinguish the image and believe that it can present reality. The specimen also needs to be carefully prepared, mounted, and stained. Just as Hooke had to consider how a fly's eye should be lit, so future generations of microscopists had to make sure that the light and dark areas were not artificial. Today's microscopes are becoming increasingly sophisticated, but do they allow people to better understand the true appearance of nature? The advent of photography in the early 19th century was thought to eliminate human error and subjective interpretation, as exemplified by photographer William Henry Fox Talbot's Pencil of Nature, published in batches from 1844 to 1846. Physicist Michael Faraday has long advocated the use of photography technology in the scientific community. He said, "The images presented by photography are beyond the reach of a paintbrush. When nature becomes the object of human photography, human potential is difficult to predict." However, the excitement about photography did not bring much results in microscopy in the early days. In the decades that followed, biologists were reluctant to bring cameras into the laboratory to highlight specimens. Instead, scientists walked into the studio and made themselves the protagonists of promotional photos. This phenomenon may be surprising, but scientists at the time were very determined to establish a reputation in society. Even after cameras appeared in laboratories, academics continued to debate the advantages and disadvantages of using cameras for objective recording. Many scientists believe that if people believe that souls will come back to life in photos, it will be difficult to rely on this technology to show the true appearance of the microscopic world. Long exposure times also make it difficult to capture moving objects. In addition, factors such as imperfect lenses, liquid splashes, and lack of color all bring uncertainties to the photographic results. In addition, the photo paper often needs to be zoomed in during the development process, and the specimen cannot be measured correctly. Size. Printing restrictions mean that photos must be processed by hand before they can be printed in large quantities, thus opening up space for human manipulation. Technicians can specifically enhance key features in the blurred details of a photo, but what is the difference between making the photo clear and distorting reality? By the beginning of the 20th century, machine reproduction of microscopic images finally defeated hand drawing. German expert Erwin Christler pointed out in an important disease illustration in 1927 that if microscopists really need to draw, they should also perform the task. Leave it to untrained technicians to achieve the closest machine-like results. Mechanization has led to progress, and microscopes have become increasingly sophisticated, revealing aspects of the natural world that had previously been speculative. Hooke would have been shocked if he saw the three-dimensional images under today's electron microscopes, which capture the most detailed stripes of insect carapace, but his dream of eliminating human influence is still elusive. Don Fawcett, the pioneer of electron microscopy, emphasized that scientific and technological progress stems from people's love for an order that cannot be faithfully represented. In the mid-1960s, Fawcett pointed out in his A Chapter of Faith that human beings believe that the authenticity of clear, and beautiful pictures is higher than that of crude, confusing, and blurred products. Even scientists, there is also a preference for a clear picture. As non-optical microscopes penetrate deeper and deeper into the previously invisible world, people are getting further and further away from reality. Today's microscopy is so complex that it requires converting electronic signals into artificially colored visual images. If Bacon had seen images of viruses under an electron microscope, he would have strongly objected, accusing science of being harmed by tribal worship and using magic mirrors to control people's minds and lead to cognitive fallacies. This article is a special article written by Patricia Farah, a senior teacher at Clare College, Cambridge University, in the June 4, 2009 issue of Nature magazine. Her latest book is Science: A History of 4,000 Years. Second. The Truth of the World. Source: ChatGPT. The truth of the world is a profound and complex philosophical question to which various schools of thought and religions offer different answers. Here are some ideas about the truth about the world. Scientific perspective. Science usually attempts to reveal the truth about the world through empirical research. The scientific method includes observation, experimentation, theory construction, and verification to obtain objective and verifiable knowledge. However, science also recognizes its own limitations, especially when dealing with issues beyond the realm of the natural sciences. Philosophical perspective. Philosophy has always pursued the understanding of fundamental truths about existence, knowledge, and value. Different philosophical schools offer different explanations, such as materialism, idealism, existentialism, etc. Some philosophers believe that truth is relative, while others believe that there is an absolute truth. Religious perspective. Religious traditions often provide a framework about the universe and the meaning of life, which often includes supernatural elements. Different religions have different views of truth, and these views are often based on faith, revelation, and sacred scriptures. Subjective experience. Some people believe that truth is subjective, meaning that everyone has their own version of the truth, based on their personal experiences, beliefs, and values. Overall, understanding the truth of the world is a multi-layered and multidimensional issue, and different people and cultures have different perspectives. In this exploration, fields such as science, philosophy, and religion provide various frameworks for thinking. Third. Simplification of the world. Source: ChatGPT. To simplify the world into easy-to-understand concepts, here's what you can do. Modeling, transforming complex phenomena into models or simple structures. This can be a mathematical model, diagram, or other form of simplified representation to make it easier to understand and analyze. Abstraction, looking for common features of things and ignoring details to make them easier to understand. Abstraction can help people capture important features while ignoring unnecessary complexity. Generalization, grouping similar things into a common concept. This helps reduce the amount of information that needs to be memorized and understood while maintaining important information. Classification, grouping things according to their similarities or functions. This helps simplify understanding of diversity while providing organization and structure. Narrative, convert complex concepts into a form that is easier to understand and remember by telling a story or using metaphors and analogies. Focus on important factors, focus on the most important factors that affect things and ignore minor details. This helps focus on core issues and reduces confusion. Use simple language, avoid using complex terminology and technical vocabulary to ensure the message is easily understood. Simplifying the world is an ongoing challenge because reality is often very complex and diverse. However, by applying these simplifications, one can better understand and cope with complexity. Note that any simplification is only an approximation and may overlook some important details. Fourth, cognitive interface theory, user interface. Source: ChatGPT. In Unreal Reality, How Evolution Hidden the Truth and Shaped Our Perception of Space and Time, Donald Hoffman did mention the concept of what he called cognitive interfaces. He uses the analogy of a user interface, suggesting that our perceptual system is an interface evolved to enable us to survive and thrive in a complex world. Hoffman argued that our perceptual systems do not directly display reality, but rather serve to provide a simplified interface that is useful to us. This interface may hide some details of the real world, but it also emphasizes information that is more important to us. In this way he explains some phenomena in psychology and neuroscience while challenging our intuitions about perception. Within this theoretical framework, a cognitive interface is a system that filters and simplifies real information to ensure that we can respond effectively to our environment. This perspective offers a unique way of understanding the way we perceive and understand the world. In Donald D. Hoffman's theory, he uses the metaphor of user interface to describe our perceptual system. This metaphor implies that our perceptions are not a direct reflection of the real world, but rather a filtered and simplified interface that has evolved to provide a useful and actionable perspective for us. The main points of this metaphor include filtering and filtering. Just as user interfaces work by simplifying complex system functionality into easy-to-understand graphics and operations, our perceptual systems work by filtering and filtering real-world information to present only the parts that are most important to us. Simplification and abstraction. User interfaces often abstract complex functions and operations into a more understandable form. Similarly, our perceptual systems may simplify and abstract the real world to make it easier for us to process and understand our environment. Useful information. The user interface is designed to provide the most useful information to the user, not all possible information. Similarly, our perceptual systems may tend to present the information most important to our survival and reproduction rather than all possible perceptual stimuli. This metaphor helps Hoffman explain some seemingly counterintuitive phenomena in psychology and neuroscience, and suggests that the way we perceive may deviate from the nature of the real world. However, this theory remains a controversial idea and has generated extensive discussion and debate in the academic community. Fifth, Donald Hoffman. Source: blog. Donald Hoffman. He is a professor of cognitive science at the University of California, Irvine, and a popular science writer. He is committed to studying consciousness, philosophy, and artificial intelligence. His articles have been scattered in Scientific American and Edge magazines. The Atlantic, Wired, Quanta and other publications have published articles on his research results. Currently lives in Irvine, California. Source: ChatGPT. Donald Hoffman is a cognitive scientist and professor at the University of California, Irvine, UCI. His research interests focus on cognitive science, neuroscience, and artificial intelligence. Hoffman's research is best known for his theoretical exploration of perception, and he proposed a compelling theory that our perceptions may be the result of an algorithm rather than a direct reflection of objective reality. His research involves the study of the theoretical and neural basis of visual perception, but also includes some philosophical discussions, especially questions about the nature of consciousness and reality. One of Hoffman's well-known theories is interface theory, which proposes that our perceptual system is not aimed at maximizing an accurate reflection of reality, but rather at maximizing information useful for survival and reproduction. His work has made him an important figure in interdisciplinary research, and his ideas have led to new thinking about fundamental questions of perception, consciousness, and reality. Please note that there is some controversy in the scientific community regarding some of the theories proposed by Hoffman, and these ideas are still being developed and discussed. 6th. Richard Russell. Source: Daily Headlines. Harvard neuroscientist Richard Russell created a visual illusion map. He had previously found that increasing the contrast in a man's face makes him more attractive, while decreasing the contrast in a man's face makes him look more pleasant. 7th. Cognition. Source: ChatGPT. The word cognition has specific meanings in psychology and neuroscience. Simply put, cognition refers to a series of mental processes related to knowledge, thinking, memory, learning and language. Here are some basic concepts related to cognition. Perception. The starting point of cognition is usually perception, the process of receiving and interpreting information from the outside world through the senses. Senses include sight, hearing, touch, smell, and taste. Memory. Memory is the process of storing and retrieving information. This includes short-term and long-term memory, as well as related processes such as forgetting and recall. Learning. Learning is the process of acquiring new knowledge and skills through experience and practice. It can be achieved through observation, imitation, trial and error, and other means. Thinking. Thinking includes higher-order mental processes such as problem-solving, decision-making, reasoning, and creative thinking. It involves the processing and analysis of information. Language. Language is a system of symbols through which people can express ideas, communicate and share knowledge. The acquisition and use of language are both part of the cognitive process. Attention. Attention is the ability to selectively focus on and process certain information among many perceptual stimuli. It involves selective attention to external and internal stimuli. Problem solving. Cognition is also related to problem solving, which includes the ability to identify problems, develop plans for solutions, and execute those plans. In the study of cognition, scientists use a variety of methods, including experiments, neuroimaging, psychological tests, etc., to gain insights into these complex psychological and neural mechanisms. Overall, cognitive research involves a deep understanding of how the brain processes information, forms memories, learns, and thinks. Source: Wikipedia. Cognition, English, cognition, refers to the mental behavior or process of obtaining knowledge and understanding through thoughts, experience, and senses. It includes many aspects of intellectual functions and processes, such as perception, attention, knowledge formation, memory and working memory, judgment and evaluation, reasoning and calculation, problem solving and decision making, comprehension and language production. Cognitive processes use existing knowledge and discover new knowledge. Analysis of cognitive processes from different perspectives in different contexts, especially in linguistics, musicology, anesthesiology, neuroscience, psychiatry, psychology, education, philosophy, anthropology, biology, systematics, logic, and computer science fields. These and other different approaches to cognitive analysis are synthesized in the developing field of cognitive science, an increasingly self-consistent discipline. 8th. Perception. Source: ChatGPT. Perception refers to the process by which an individual receives, analyzes, and understands external stimuli through the senses. Perception is a part of the cognitive process that involves the action of sensory systems, including vision, hearing, touch, smell, and taste. Here are some basic concepts about perception. Sensory organs. Human sensory organs include eyes, ears, skin, nose, and tongue. These organs are sensitive to external stimuli, convert the stimuli into neural signals, and then send them to the brain for further processing. Perception threshold. Perception threshold refers to the intensity of a stimulus that must reach a certain level before an individual can perceive it. Subthreshold stimuli may go unnoticed. Perceptual organization. Perception is not just the perception of a single sensory stimulus, but also involves the ability to integrate multiple sensory information into a meaningful whole. This includes the integration of visual, auditory, and other sensory information. Perceptual distortion. Sometimes the sensory system is affected by various factors, resulting in a distortion or false perception of a stimulus. This can include visual illusions, auditory illusions, and other sensory distortions. Adaptation. Sensory adaptation is when a sensory system is exposed to ongoing stimuli. The perceptual system may adjust its perception of the stimulus to increase sensitivity to new stimuli. Sensory experience. Sensory experience refers to an individual's perception and experience of the outside world through the senses. This includes the perception of visual scenes, the perception of auditory sounds, and the perceptual experience of other senses. Perception is the fundamental means by which we interact with our surroundings, providing us with an understanding of the world. The process of perception is affected by factors such as the individual's physiological state, experience, and culture. Source: Wikipedia. Perception is the brain's overall view and understanding of the outside world when external stimuli act on the senses, organizing and interpreting sensory information from the outside world for us. In cognitive science, it can also be regarded as a set of procedures, including obtaining information, understanding information, filtering information, and organizing information. It is higher order than feeling. High order means more complex and requires more layers of psychological and physiological mechanisms. The low-level feeling is to detect the existence itself. To feel the transition between perceptions is to roughly recognize someone or something. At the perceptual level, one can identify his or her identity. One of the biggest differences is that perception has signals added to subjective understanding. Perception is inseparable from personal past knowledge and experience. In 1963, Miller and Isard conducted an auditory experiment in which they added a lot of noise to English sentences and asked subjects to listen. These English sentences can be divided into three categories: sentences with normal grammar and meaning, sentences with correct grammar but wrong semantics, and sentences with ridiculously wrong grammar and meaning. The experimental results found that no matter how loud or small the noise was, subjects were most likely to correctly perceive sentences with normal grammar and meaning, and least likely to correctly perceive sentences with absurdly wrong grammar and meaning. Such differences show that people can apply knowledge of grammar and semantics to perception, so knowledge and perception are closely integrated. 9th. Checkerboard shadow illusion. Source: ChatGPT. The checker shadow illusion is a visual illusion that exhibits characteristics of our visual system. The illusion, originally created by Irish psychologist Akiyoshi Kintaka, exploits the way the visual system perceives shadows and light to create a seemingly illogical visual effect. This illusion is usually performed on a checkerboard pattern with two squares, one placed in a bright area and the other in shadow. Even though the two squares are actually the same color, due to the clever use of surrounding light and shadow, our visual system will mistakenly think that the square in the shadow is darker than the square in the bright area, when in fact they are the same color. This illusion is primarily caused by our brains trying to interpret the color of an object as the color of the object itself, rather than the color of the light hitting it. This is also why the two squares are considered different colors in this case. This illusion highlights the sensitivity of our visual system to light, shadow, and background color. Source: Wikipedia. The checkerboard shadow illusion was published by MIT professor Edward H. Adelson in 1995. This image file depicts a white and black square chessboard. The square marked A appears to be darker than the square marked B, but they are actually the exact same shade of gray. The fact that the two chess squares are exactly the same color can be proven by: open the image directly with drawing software and use the color picker function to confirm directly. After using cardboard to cover all parts other than these two chess squares, you will only see the colors of these two chess squares without being visually disturbed by the graphics next to them. Actually print out the image and cut out only the two chess pieces for direct comparison. Measure with photometer. Regarding the optical illusion caused by this image, Professor Adelson explained as follows. The human visual system makes judgments about the real-world color of the objects it sees. In this case, to determine the color of the checkerboard beneath the shadows, the actual light received by the eye is not enough. The human visual system uses several tricks to compensate to determine the color of gray paint on a surface. The first technique is the contrast of local areas. Whether under shadow or not, a tile that is lighter than the surrounding area may generally be lighter, and vice versa. So in this image, the brighter B chessboard in the shadow is surrounded by other darker chessboards. Even though the eyes actually receive darker light, the visual perception is relatively bright. On the contrary, the bright square A is surrounded by brighter squares, thus making it look darker. The second technique is based on the fact that the color changes produced by shadows usually have blurred changes, while the paint on the surface of the object, such as the color on the chessboard, usually has sharp edges. The visual system tends to ignore gradual color differences, thus ensuring that the color of a surface is not misled by shadows. In this image, the middle shaded area looks like a shadow because its edges are blurred and the cylinder that creates the shadow is visible. Judging the color of the chess square lacquer is surrounded by 4 adjacent chess squares. This type of combination is usually a hint signal, that is, the color change of the edge of the chess square is the color change of lacquer, and the chess square internal color changes are the effect of shadows or lighting. Like many so-called optical illusions, this effect does suggest a success, not a malfunction, of the human visual system. The human visual system does not perform well as a physical light meter, but that is not its purpose. The important task of the visual system is to convert the received light signals into meaningful components and thereby determine the nature of the objects in the image. 10th. Sexual tension. Source: Zhu. Regarding the meaning of this word, it can be said that thousands of people have thousands of faces. Today we will talk about this word. Are sexual tension and sexiness equivalent? Sexual tension does not entirely refer to sexiness. Strictly speaking, it refers to just the right amount of gender attraction. If it is more, it is greasy and vulgar, and if it is less, it is salty and tasteless. What is tension? We often mention the tension of words, the tension of performance, and the tension of art. Going back to the basics of physics, we see that it is an unstoppable inner force, wrapped in powerful energy. Sexual tension means the dynamic balance of the body releasing and withdrawing two opposing forces. Sexual tension in the traditional sense is related to the love between men and women, and can even be easily interpreted as sexy. In fact, sexual tension is a specific aura, not a superficial temptation, but the highest level of attraction. Generally speaking, sexual tension has a mature texture, contrasting conflicts, and rich layers. Mature texture. Be able to navigate a complex world with ease, maintain the ability to actively deal with anything, and be courageous and determined. Allow everything to happen, be in control of things, and show the sense of relaxation that comes with a high degree of self-acceptance. Strong vitality, stable emotions, and strong desires maintain a delicate state of checks and balances in this person. This forms a very personal temperament, a personal charm that can attract others, and a wisdom that can appropriately demonstrate the inner and one's own advantages. The appearance or figure may not necessarily be beautiful and exquisite, but it must have excellent charm and outstanding posture. At a glance, people will understand, wow, this is a mature man/woman. Conflict of contrast. People with full sexual tension can make people smell desire. It's just that desire is wrapped up and can be released selectively, with a certain degree of relaxation. This suppressed desire, the attraction that leaks out from certain cracks, is even more deadly. To a certain extent, sexual tension and abstinence are synonymous. The body secretes hormones but remains tolerant in certain situations or scenes. The so-called ideological overpowering has a sense of contradiction. Sexual tension is different from the overt and wanton sexual desire, which releases all desires, but an inner resistance to one's own desires, like 10,000 beasts galloping in the heart, which is subjectively forced to cut. It's this conscious conflict that's fascinating. Rich levels. Where does this Zhang expand? It expands infinitely in people's imagination. This kind of tension can reveal more unexpressed or deliberately hidden information just from a character's expression, reaction, action, or words. Human desire and subjective will, these two polar opposite forces pull back and forth in the body. When reason prevails, one is calm and composed, but when desire prevails, one is dangerous and confused. This fierce inner struggle creates a strong sense of depth for the characters. What you see is just the tip of the iceberg, which is the result of multiple conflicts and struggles, with undercurrents surging underneath. That is to say, we praise this person is so rich in content. At this time, the character is no longer thin and forms a field. The term sexual tension is actually a bit metaphysical. It cannot be seen or touched, it can only be understood. 11th. Time and space do not exist. Source: ChatGPT. From the traditional perspective of physics, space-time is the basic framework in the universe, describing the interaction between time and space. However, in some theories of high-energy physics and cosmology, there are some different views and assumptions about the structure of space-time. Here are some theories or concepts that explore the possible non-existence of space and time. Quantum space. Some quantum gravity theories propose a reinterpretation of the structure of space-time. These theories attempt to combine quantum mechanics and gravity, and deal with the concepts of space and time through quantum processing, in order to provide a unified description of micro and macro phenomena. Illusory time. In some cosmological theories, such as Stephen Hawking's concept of virtual time, time is regarded as a virtual dimension with characteristics similar to the spatial dimension. This perspective challenges our habitual perception of the single flow of time. Superstring theory. Superstring theory is a theory that seeks to unify all fundamental particles and forces of nature. In this theory, the number of space-time dimensions may be different from the 3 dimensions of space and 1 dimension of time in our everyday experience. These theories and concepts are still in the scientific research stage, and their feasibility and authenticity have not yet been fully empirically supported. Currently, a combination of traditional relativity and quantum mechanics, such as M-theory, remains the dominant theory describing time and space in the universe. Source: Today Weekly. The essence of the material world is illusion and fiction. Planck, the founder of quantum mechanics, discovered that in the material world, light is not a wave, but a discrete particle called a photon. Because of this discovery, the scientific research of quantum mechanics was founded. The material world turns out to be composed of virtual bodies similar to pixel particles, rather than a continuous and smooth entity. The physical concept of quantum is the transfer and passage of time and space, which must not be less than a certain minimum amount. Quantum is not a continuous change, but a discontinuous change process. The smallest space unit of the universe is the Planck length, which is 10 to the 33rd power of 1 centimeter. The minimum time interval is the Planck time, which is 10 to the 43rd power of 1 second. Below this scale, gravity and time and space do not exist. Quantum discontinuity means that the material world comes out one by one and then disappears, rather than having only one continuous entity that has existed forever. Spatial discontinuity. The inside of an atom is 99.999999% empty. Our body is composed of atoms one by one, so the human body is basically a void body, just like a combination of pixel particles on a computer screen or a photo, rather than continuously smooth solids. Only the projected image can explain the occurrence of this phenomenon. Discontinuity of space and discontinuity of time. The discontinuity of time and space shows that the material world is basically a kind of illusion image that plays continuously. The photos in the film are played frame by frame and then disappear without a trace. Time is not continuous. Time passes bit by bit in intermittent intervals, which means that the material world comes into being and then disappears one by one. This shows that the material world is fictionalized one by one out of nothing, rather than just one thing that has already existed forever. Therefore, the essence of the material world is illusion and fiction. It is a game and a dream of the soul in the black hole, spiritual world. It is the continuous projection of momentary thoughts. It is the projection of virtual particles in the black hole. The spiritual world is real and eternal. Friends who firmly believe in materialism, please don't think it's ridiculous or unbelievable when I say that the nature of the material world is both illusion and fiction. This is specifically described by the theory of quantum mechanics. It also shows that quantum thinking is idealism. This argument has long been promoted by idealist philosophers thousands of years ago, such as Lao Tzu, Plato, and Buddha. This is simply a commonplace point of view, the encounter and recognition of science and philosophy. In his Utopia, Plato proposed the cave theory, which compared the material world to the shadow of the soul. 4 verses from the Diamond Sutra: all conditioned dharmas are like bubbles in a dream, like dew or lightning, and should be viewed as such. Unconditioned dharmas are the soul, while conditioned dharmas are all things that are fictitious in the illusory material world. As long as an idea is attached to one point, a world will be born. An idea, an emotion, a creativity, an obsession, the entire universe evolves because of it. Since ancient times, people have used Maya to define life experiences. These are illusory and come from your self-identity, your thoughts, emotions, and obsessions. As long as one of them exists, the world will continue to evolve and the universe will be born. Everyone has their own universe, and it seems very real, more real than reality, so people don't have time to understand reality. Donald, a professor of cognitive science at the University of California, Irvine. Donald Hoffman has devoted more than 30 years to studying human perception, artificial intelligence, evolutionary game theory, and the human brain. His conclusion: the world the brain presents to us is not the real world. Everything in the world is an illusion to some extent. Consciousness creates the universe, and the material world is a process of being created, not a process of discovery. All good things require you to set goals first, and then work hard to create and realize them. You can never find them by searching outside. And all of this comes from the powerful creative power within you. 12th. Two-dimensional creature, ant. Source: ChatGPT. Ants are real-world creatures that are arthropods that are usually classified as insects. Although ants are three-dimensional creatures, this question may refer to the behavior of ants in certain situations, which has some similarities with some characteristics of two-dimensional creatures. An interesting problem in computer science and mathematics is the ant maze, in which ants can only move on a two-dimensional surface, such as a square grid on a plane. Such models can be used to study the way ants find food and establish colonies under specific conditions. In this case, the movement of ants can be modeled as walking in two-dimensional space. Such a model might include simple rules, such as how ants turn, advance, or stay based on their surroundings. This two-dimensional model can be used to study how ants search their environment in a decentralized manner and how they work cooperatively with their peers. Overall, while ants in reality are three-dimensional creatures, within specific computer models and mathematical problems, we can model their movement and behavior as movement in two-dimensional space. In the real world, we have yet to observe organisms with planar, two-dimensional, living structures. All known living things are three-dimensional, that is, they have length, width, and height. The three-dimensional structure of living organisms helps them perform various physiological activities, including absorbing nutrients, moving, and reproducing. In theory, there are some concepts about two-dimensional life, especially in computer science and mathematics. Take, for example, Conway's game of life, a cellular automaton based on simple rules in which life forms evolve in a two-dimensional grid. However, this is only a simulation and abstraction and does not represent real two-dimensional creatures. In nature, all known living organisms have a certain thickness and volume that allows them to exist and interact in three dimensions. Therefore, there is currently no observational or scientific evidence of actual two-dimensional creatures. Source: YouTube. Are ants really two-dimensional creatures? After listening to the scientist's explanation, I suddenly realized. Since scientists proposed the theory of multidimensional space, exploration and research on dimensions have been ongoing. Multidimensional space refers to a space composed of 4 or more dimensions. Definition of multidimensional space: dimension is a measurement on the three-dimensional space coordinates, plus time. Space and time are interconnected to form a four-dimensional space and time. Our usual concept of space refers to a three-dimensional space consisting of length, width, and height. The world in which humans live is a three-dimensional space, and creatures living in a three-dimensional space are three-dimensional creatures. Then there will be existence in a three-dimensional space. Two-dimensional creatures? In the eyes of many people, this is impossible. How can two-dimensional creatures be allowed to exist in three-dimensional space? I believe many friends can often see discussions about tiny creatures like ants on the internet. Why are many people, including scientists, very curious about ants? You know, for humans, ants are too small. Although ants are very small, they are very extraordinary. First of all, ants are just like our human society. Different forms have different social divisions of labor. All Formicidae live in social groups. There are generally 4 different types of ants in a colony, and each type of ant has its own job and responsibilities. Secondly, ants are real strong men. Despite their small size, they can lift food several times heavier than their own bodies. This may be something only ants can do in nature. Finally, there is the special vision of ants. So how is the vision of ants different from other creatures? The biggest difference is that ants' vision is two-dimensional. In other words, in the ant's visual world, it can only perceive length and width, but not height. Scientists have conducted experiments on this two-dimensional vision of ants. They hoisted the food in front of the ant slightly above the ant's head. If it is a real creature, after you hang the food in front of them, they can still know that the food is on it. Then take the food back, but the ants are different. When the food leaves their front and runs to their heads, they will be at a loss. If you are observing ants, you will feel that the ants are so stupid. The food is obviously above their heads and you can see it as long as you raise your head, but why can't you see it? In fact, this cannot be blamed on the ants, but their vision is two-dimensional and cannot perceive the height of things. Since the vision of ants is two-dimensional, does that mean that ants are two-dimensional creatures? Of course not. In fact, in the eyes of humans, ants are also creatures with length, width, and height. Naturally, they are also three-dimensional creatures, not two-dimensional creatures. In fact, the relevant dimensions are only a guess among scientists at present, and there is currently no definite answer to whether there is a multidimensional space. Even if dimensional space is real, it is still unknown whether two-dimensional creatures exist. However, from the perspective of ants' two-dimensional vision, the theory of dimensions is most likely correct, and multidimensional space is most likely real. Since the vision of ants only has two-dimensional perception, the world of ants is a flat world, just like we are watching TV. Ants have only length and width in front of them, but no height, so they can only sweep the food that exists in the flat space. Once the food reaches above their heads, they cannot sense it. Some people may say, if the ant's head touches the food above, wouldn't it know? And indeed it is. Many people may laugh at the fact that the field of vision of ants is too narrow and they can only perceive a two-dimensional space. It is so pitiful. But in fact, in the world of ants, they do not feel pitiful, but feel that this is the world they really live in. If ants are intelligent creatures, then scientists among ants may also propose a multidimensional space theory. They also want to know whether there are three-dimensional space, four-dimensional space, etc. above the two-dimensional world. They also panic about things disappearing in front of them, and they become a mystery in the ant scientific community. So from a dimensional perspective, the situation of human beings is actually similar to that of ants. Many people may think that human senses are three-dimensional, and we can see a three-dimensional world, which is much better than ants. But in fact, mysterious disappearances have also occurred in the human world, and we will also feel scared and panicked by these disappearances. For example, if you are chatting with a friend and suddenly your friend mysteriously disappears in front of you, would you feel scared? Your first reaction will naturally be to panic. When the panic passes, you will have some questions. Where are my friends? Why did he mysteriously disappear? Is it paranormal or something else? In human three-dimensional perception, we cannot explain the disappearance of your friend. This disappearance may be the same as the disappearance of the food in front of it in the world of ants. Maybe your friend didn't disappear at all, but just entered the four-dimensional space. He may still be in front of you, but you can't see it. The reason is that humans are three-dimensional creatures and can only perceive creatures below three-dimensional space. The four-dimensional space is based on the three-dimensional space and adds the concept of time. Although we deal with time every day, we have almost no awareness of time. And the time we think of is only defined by humans. What is the essence of time? We know nothing about it, and scientists have conducted a lot of time exploration and research, but so far they have not been able to decipher its mystery. Time is a mysterious thing for three-dimensional creatures, but for four-dimensional creatures, time may be very simple. Just like our understanding of heights, it is actually very simple. The reason is that in the four-dimensional space, time is a basic dimensional quantity and a real thing, and in the eyes of four-dimensional creatures, time can be seen. Therefore, some scientists speculate that different times in four-dimensional space can exist at the same time. For example, the past, present and future can be seen at the same time. If humans enter the four-dimensional space, they may be able to watch it on different timelines. You can see yourself as a child and you can see yourself in the future. In four-dimensional space, time is not mysterious at all, but in three-dimensional space, time is a very mysterious thing. Even scientists cannot be sure whether time really exists. In the same way, for ants with only two-dimensional visual perception, height is also a mysterious thing, and they cannot determine whether height exists. Of course, for ants, they will not study mysterious heights and can live in a two-dimensional world without any care. But it's different for humans. Because we are intelligent beings, we have created powerful technology, and the power of technology has given us initial access to the dimensional world. As the saying goes, the more you know, the more you will feel the insignificance of human beings. We cannot ignore the exploration and research of dimensions. If the multidimensional space theory is correct, four-dimensional space, five-dimensional space, etc. are real. So if we don't work hard to study and explore it, it is possible that in the future, humans will face the invasion of high-dimensional creatures. Only when we have a comprehensive understanding of dimensional space can we actively deal with anything related to dimensions that may occur. 13th. Biological clock. Source: ChatGPT. The biological clock refers to a time perception mechanism that exists within an organism, which allows the organism to adjust its physiological and behavioral activities according to periodic changes in the environment. This internal time-sensing system is critical to the survival and reproduction of living things, because it helps organisms adapt to the changes in day and night, seasons, and other cyclical changes on the Earth. Here are some basic concepts about the biological clock. Biological clock, the biological clock is controlled by the physiological mechanism inside the organism. These biological clocks regulate various activities of organisms through periodic biochemical processes or neural signals. Environmental regulation: the circadian clock is usually able to sense time signals from the environment, such as changes in light and temperature. In many organisms, light is an important temporal signal, especially in relation to the circadian cycle. Cycle: different biological clocks may have different cycles, called cycles. Some organisms may have circadian clocks with a 24-hour cycle that matches the Earth's day-night cycle, while other organisms may have circadian clocks that are aligned with other environmental cycles. Adjustment and synchronization: the circadian clock can be adjusted and synchronized by time signals in the environment. This adjustment process is called the correction of the biological clock. Light is a common corrective signal. For example, changes in sunrise and sunset can help organisms adjust their circadian clocks. Importance: the biological clock is essential for maintaining the physiological balance, proper metabolism, reproduction, and other life activities of organisms. Loss of the ability to perceive time may lead to physiological disorders in an organism. The study of biological clocks is of great significance to understanding the adaptability and behavioral patterns of organisms, as well as the regulation mechanism of life activities. Source: Wikipedia. The biological clock is the internal rhythm of biological life activities. Through it, living things can sense the periodic changes in the external environment and adjust the pace of their own physiological activities so that they start, proceed, or end in a certain period. In nature, when the rhythm of life matches the rhythm of the natural environment, life can survive better and be preserved by natural selection in the process of biological evolution. From the perspective of biological evolution and natural selection principles, all life phenomena on Earth are the result of nature's evolutionary selection of organisms to adapt to the environment. Since life appeared about 1 billion years after the formation of the Earth, from its birth, the biochemical reactions between the simplest biomolecules of life have been affected by various substances and environmental factors that already existed on the Earth, and subsequent changes have also all are under the control of the Earth's environment. Therefore, all activities of life on Earth are affected by the cyclic rhythm of the Earth. All biological rhythms are also the result of the environment's selection of biological evolution. 14th. Aging and time. Source: ChatGPT. There is a close relationship between aging and time, which is a common phenomenon in the life process. Although our understanding of the exact mechanisms of aging is still limited, many studies have shown that time has an important influence on the aging process of organisms. Here are some connections between aging and time. Physiological aging: over time, cells, tissues, and organs undergo a series of physiological changes, including the slowdown of cell division, the accumulation of DNA damage, and the failure of protein quality control. These changes lead to the occurrence of physiological aging. Genetics and environment: aging is a complex process influenced by genetics and environment. Genetic factors can affect the rate of aging of a person during life, while environmental factors such as diet, lifestyle, environmental exposure, etc. also have an impact on aging. The passage of time creates a cumulative effect for these factors. Accumulation of damage: the passage of time means that the organism is continuously exposed to external and internal factors. This leads to the accumulation of damage in organisms, including DNA damage, aging of cells and organs, etc., ultimately affecting overall physiological functions. Immune system decline: over time, the immune system also undergoes changes that include a decrease in the number and function of immune cells. This makes individuals more vulnerable to infection and disease. Hormonal changes: as we age, hormonal levels also change, which affects the regulation of physiological systems. For example, women experience a drop in estrogen levels and men experience a drop in testosterone levels during menopause. Overall, time is a factor in aging, but it's not the only factor. Researchers are still deeply studying the molecular and cellular mechanisms of aging in order to better understand and intervene in the relationship with time and the aging of organisms. While we are currently unable to prevent or reverse aging, continued advances in healthy lifestyles, appropriate medical research, and biotechnology can influence the rate and pattern of aging. 15th. Can we build a mathematical model of consciousness? Source: Life Big Data. Donald Hoffman, can we build a mathematical model of consciousness? Donald Hoffman. American cognitive psychologist, popular science writer, professor in the Department of Cognitive Science at the University of California, Irvine, and jointly teaches in the Department of Philosophy, Department of Logic and Philosophy of Science, and Department of Computer Science. From the moment people are born, they will have various perceptions of the world. For example, visually, the sun is golden, and the sea and sky are blue. However, do these perceptions, processed by the brain, really reflect reality? What is the relationship between consciousness and the brain? With the development of artificial intelligence and other technologies, can machines possess consciousness to a certain extent? And in further research, can we get a glimpse of the true face of consciousness from deeper models and theories? In this issue, the questioning team interviewed Professor Donald Hoffman, an American cognitive psychologist, popular science writer, and Department of Cognitive Science at the University of California, Irvine. Professor Hoffman will lead us to understand human consciousness and perception. Related research. The following is the specific content. Can you briefly introduce your field of research and why you chose it? Donald: I study visual perception. How do humans see the world from a three-dimensional perspective? How do we see colors and recognize objects? I also study consciousness. How does our experience of color, taste, and smell relate to reactivity? How do we understand consciousness? More broadly, can we come up with a scientific theory of consciousness? I'm also interested in artificial intelligence. Is artificial intelligence conscious in some sense? I'm very interested in this question. Are humans just machines? Or are we beyond machines? If so, what might that existence look like? To truly answer this question, one way is to participate in artificial intelligence research. How far can we make machines go? What can we do with machines? Can we really make machines conscious? I also want to study human neuroscience and human psychology, asking questions from a human perspective. What does it mean to be conscious? What does it mean to be human? How does it relate to our neurobiology? With these questions in mind, I came to MIT to work in the Artificial Intelligence Laboratory and now the Department of Brain and Cognitive Sciences. I can see both sides of this issue. One is artificial intelligence and the other is human neuroscience and cognitive science. I have been doing research on this for the past few decades. Now, I'm working on artificial intelligence, computer models of intelligence, and computer models of human visual processing, human perception, and so on. That's something that I've always been interested in, and that's the area that I look at from an evolutionary perspective. Has evolution shaped our senses and shown us the true makeup of objective reality? These are things that I've been interested in for a long time. All in all, what does consciousness have to do with the brain? Can artificial intelligence be consciousness? How will we fully understand this very interesting question? Most people probably think human perception is real, but you seem to disagree. What good are our senses if they cannot convey the real world? Donald: yes, most of us take it for granted that evolution shaped our senses, such as sight and hearing, to allow us to understand the truth about the world. Because that will make you more adaptable to the world, make you more likely to succeed, let you live long enough, and then have children to continue your genes. Most of us believe these claims based solely on intuition. But when you actually study the theory of evolution through natural selection, as if you put it in a mathematical framework called evolutionary game theory, it turns out that we can ask questions with mathematical precision. This problem: What are the chances that natural selection will shape any sensory system to reveal truth about the structure of objective reality? The result of mathematical calculation is, this possibility is zero. According to evolutionary game theory, no sensory system of any organism can be shaped to reveal the truth of objective reality. People always comment to me that it is impossible for me to achieve this result, that I must be doing something self-refuting, that my words and actions are contradictory. I don't mean I believe in evolution, I just think it's the best existing theory so far. As a scientist, I have to use the best theory available, and there is currently no better theory than evolution. I'm an agnostic and I don't know if evolution is true. I guess it captures a lot of good points. If we find a deeper theory, whatever it is, it better look like the result of evolution by natural selection under some extreme circumstances. So when we look at evolutionary theory and just focus on the mathematically relevant parts, we see something very simple, called fitness payoff functions. Payoffs sort of determine what happens when you take steps. What, if I take this action, will I be more or less well adjusted? These adaptive payoff functions determine the adaptive consequences of various actions you take in different situations. You may be in a variety of situations. If I'm hungry and want to eat, a carrot or a piece of meat might be perfect for me. But if I want to mate, the same food won't help me at all. So fitness gains depend on the state of the organism, such as whether it's hungry. When you look at these adaptive payoff functions, it turns out that we've performed this function in 3 or 4 special cases, but I'm sure overall the probability is zero. The adaptive gains that govern evolution have no information at all about the structure of the world. They don't allow you to fit into the structure. It's that simple. We've made other arguments, but I think this theory is pretty shocking. Does objective reality exist that is independent of the observer? Or maybe the external world is just a cognitive illusion constructed by neurons? Donald, it depends on what we mean by external reality. If you're referring to space, time, and physical objects around us, like trees, the moon, and the stars, then I do think reality doesn't exist independently of us. I think space-time is just a data structure we use, and objects are entities within that data structure. From an evolutionary perspective, it's all about guiding adaptive behavior rather than seeing the truth. From an evolutionary perspective, seeing the truth will not make you more adaptable, but will lead to your demise. What we see is not the truth, space and time, and physical objects. That is not the truth. I think of it like a virtual reality headset that evolution has given us to play a game called life without knowing what reality we are interacting with. I believe there is a deeper reality that transcends time and space regardless of whether I am aware of its existence or not. If I weren't here, that reality would still be there. So, in this sense, objective reality exists. But it's unlike anything we've seen, it's not anything in space and time, and it's not a physical object. You proposed the fitness beats truth principle, arguing that what we perceive is not objective reality, but only part of the species-specific perceptual interface. Does this mean that what we perceive is a model of the world? Is there a cognitive model that describes this process? Can you give some examples? Donald, I would say that in a sense evolution has not given us a model of the world. It just gives us a user interface to successfully play the game of life. For example, if you're playing an open-world VR game and you see a red Mustang or a white Porsche, you're not seeing a model of reality. By analogy, reality would be some supercomputer you can't see. What you're really doing in reality is converting millions of voltages per second to play the game. But in a sense, the Porsche you see is not a model of a supercomputer. You'd never guess from a Porsche that you're looking at a supercomputer converting millions of voltages. In this sense, it is not a model. Evolution has not given us a model of reality, but only a headset that completely hides the nature of objective reality. Whatever its nature, you don't need it. This is what evolution has brought about. There may be a deeper point, which is that we have real insights into some aspects of reality. A lot of people think I'm contradicting myself, so I have to be very careful. If you just look at evolution strictly in terms of natural selection, then we don't see reality because what we see is not reality. I don't have to believe in evolution by natural selection, but instead propose a different structure. I had to show how this deeper structure produces evolution by natural selection. Perhaps there is a deeper structure within which we can indeed see certain aspects of reality. Perhaps our experiences of love, certain emotions, or certain spiritual feelings are real insights into some nature of reality. And evolution by natural selection does not allow this, but there may be a deeper perspective that allows it. This view holds that our insights into consciousness may be genuine insights. As scientists, whatever deeper point we make, we must be able to show how evolution by natural selection fits this deeper reality as a special case. Philosophers like to put scientists into these little logically contradictory situations from which you can't escape. Scientists are doing something different. I'm not wedded to any theory. I mean, if you take this theory, then you get this result, but we may be able to discover a deeper theory. The results obtained previously are only correct in the context of evolutionary theory. In a broader scenario, such results may not apply. You can look at a formal system, but you can also understand it from a meta perspective and demonstrate things that are beyond the power of this system, or understand things that are beyond the power of this formal system. I can understand a lot of philosophers having this attitude because they don't really understand that the scientific community is doing something different than the philosophical community. I don't want to have any internal contradictions in a theory. But when we look at different structures, we see that one structure will lead to another, broader structure. Then those gotcha-type arguments break down. In recent years, the use of computational models to explain the brain has become a trend. Is the computational model that performs well in the engineering field necessarily the model closest to the cognitive mechanism of the human brain? Computational models are a really good framework for understanding the human brain and what it's doing. I was doing this when I was at MIT, where I was mentored by David Marr, who pioneered computational models of visual perception. We were studying computer vision as well as human neuroscience, visual neuroscience, looking at the two and how they interact. I think this is a fantastic multidisciplinary approach to the whole problem and I highly recommend it. But most of my colleagues believe that neurons and brains exist objectively even if they are not perceived. In other words, they believe that neurons and brains are real, regardless of whether they are perceived or not. My attitude is that if you take evolution by natural selection seriously, then such a view contradicts the theory, because natural selection thinks that objects in spacetime are just a user interface, they are not the reality, that objects in spacetime include brains and neurons, they are just interface symbols, not the truth. This doesn't mean we need to forget about neuroscience, it means neuroscience is much more difficult, and we need more funding to support neuroscience. We think that when a person looks through a microscope and sees neurons and axons and dendrites and synapses and so on, that this is what is really there, that this is the truth, that this person knows what is going on, but that is not the case. All of this neurons and their properties are just interface symbols. We have to reverse engineer all of these symbols in terms of a deeper reality that transcends time and space to understand how that deeper reality projects into the neurons and their properties and neuronal networks that we see. I'm all for computational models and neural network models, and using mathematics and so on to study the brain. But I think evolution teaches us that this work is much more complex than we thought, and much deeper than we thought. You see neurons, but that doesn't mean there are neurons in reality. That's just what the interface you are interacting with reality is doing. You have to learn to transcend the interface. It's not easy, it's a bit like looking at your own eyes and appearance, and then seeing beyond what your eyes bring. This is what science does. We just need to be aware of what the theory tells us and then follow where the scientific theory leads, even if we don't like it. By the way, it's not just evolution that tells us this. Physicists are telling us the same thing. Physicists tell us that spacetime is not essential and is doomed. They are looking for new structures, such as amplitude polyhedra and cosmological polytopes, that transcends space and time. Although science has for centuries considered space and time, or space-time as a whole, to be fundamental realities, science can easily move away from this idea and leave it with, time and space are interesting. We once thought they were fundamental. But that's not the case. Now let's look for new structures that transcend space and time. Science can do that. So, we're doing that, but of course it's going to be a lot harder than we thought. We once thought that space and time were just this structure and that we could understand space and time this way, but it turns out that this was just a warm-up. That's the headset we play the VR game Life with, and we're just beginning to understand it now. We have to look beyond the headset to understand reality. As you mentioned, physics plays an important role in understanding the world. According to the von Neumann-Wigner interpretation, there is no objective world, it is created by consciousness. Whether you support this view or not, the most mysterious thing about the brain is consciousness. What do you think consciousness is? How did it come about? How does it relate to our perception, cognition, memory, etc.? Donald, many early quantum theorists, such as Wegener and von Neumann, talked about consciousness as the basis for explaining quantum theory. Somehow, you need some kind of consciousness to achieve what they call collapse the wave function. You have some wave function, like the Schrödinger equation, which evolves over time, and you don't get a complete and specific answer, unless you collapse the corresponding wave function in some way and give yourself a specific answer. What is the position of that particle? What's the momentum? You have to get an answer. They suggested that perhaps the collapse was caused by consciousness. I think their research is close to the truth, but recent physicists tend to move away from this view. Recent physicists do not like the idea that consciousness is fundamental. I would say that 99% of my colleagues in the field of consciousness and in the field of cognitive neuroscience who study consciousness believe that space, time, and physical objects are fundamental realities. Consciousness arises from complex interactions between matter, such as neurons, or perhaps silicon circuits in appropriately programmed artificial intelligence. They believed that the physical world was the foundation and then consciousness emerged. A panpsychist would say that the physical world is fundamental, that the laws of physics are fundamental, but that consciousness is either another property of the particle, or the fundamental reality of the particle. There are two different versions of panpsychism. But they believe that space, time, and particles are fundamental realities. Again, the best science tells us this is not the case. As a scientist, I take physics and evolution by natural selection seriously. These theories tell us that space and time are not fundamental. So, although my colleagues are very good, at least 99%, if not all, of the theories about consciousness they are working on are impossible to demonstrate because they assume that space, time, and particles are fundamental realities. Even the dualist framework is incorrect, since dualism is at least half about space and time. My attitude is, I don't know what reality is. But why not start with a mathematical model of consciousness? Think of consciousness as an independent research object, rather than something born in neurons, something that does not emerge from the complex circuits of artificial intelligence, and a consciousness completely outside of time and space. Let's try to build a mathematical model of consciousness and show how space and time are just a VR headset, just a virtual reality, which we call conscious agents. Some conscious subjects view this headset as a way to interact with other conscious subjects and understand their interactions with each other. We need to do the opposite. Science considers space and time to be fundamental, and consciousness comes later. Let's think about it the other way around. Consciousness is the foundation, and space and time are just one of billions of different head-mounted devices that conscious subjects can use to understand and interact with each other. This completely subverts the original thinking logic. Many scientists believe that the essence of consciousness lies at the quantum level. But in quantum mechanics, two states exist in superposition at the same time, and the observation itself will participate in the experimental process and affect the experimental results. In this state, the causal order and the time-oriented sequence state no longer exist. How should we understand time? How should we understand the meaning of cause and effect? Donald, the first thing I want to say is that people think of quantum mechanics as fundamental physics. It turns out not to be. Quantum mechanics is not fundamental. When we let go of space and time, we also have to let go of quantum theory, because the two go hand in hand. Physicists like Nima Arkani-Haim say we need to find deeper physics beyond space-time and quantum theory. These structures beyond space and time have no Hilbert space, no quantum theory, and no amplitude polyhedron. What they show is that space-time and quantum theory come together as a virtual reality headset. Translator's note. Hilbert space was proposed by German mathematician David Hilbert. He studied Hilbert spaces in his studies of integral equations. Von Neumann first used the term Hilbert space in his 1929 book on unbounded Hermitian operators. It is a direct generalization of Euclidean space. The study of Hilbert spaces and operators acting on Hilbert spaces is an important part of functional analysis. We believe that through quantum theory we have accessed the deepest and most fundamental mathematical models of physics. Behind quantum theory, there is a deeper structure called an amplitude polyhedron. Believe it or not, at its core is something called decorated permutations. These structures are much deeper than quantum theory. As for time, in our space-time model, time and cause are fundamental properties. In quantum field theory, time is a fundamental parameter. In the evolutionary process of natural selection, time is the most critical limited resource. But it turns out that we can have dynamics of conscious subjects that are mathematically precise and have no entropic time. The entropy of a kinetic is constant, it does not increase as the kinetic sequence continues. In this sense, dynamics does not have the sense of time of entropy like the sense of time of the second law of thermodynamics. It is easy to show that any projection of such Markovian dynamics has entropic time. When you project by conditional probability, it's a trivial demonstration of the kind of limited perspective that projection has on deeper dynamics, that there must be an entropic time, like the arrow of time, straight ahead, never look back. I believe that time and entropy are not fundamental, but merely products of projection. When you go into a deeper reality where there is no entropic time and you look at it from a finite perspective, then as a product of your limitations, you get quantum theory, you get time, you get the second law of thermodynamics. One characteristic of causation is that the cause must precede the effect. Without the concept of succession and the concept of entropic time, then we have to think about the whole concept of causation in a more fundamental way. Neither space nor time are fundamental concepts, which forces us to dig deeper into the concept of cause and effect. In a quantum setting, you can set up loops that violate causality. Although quantum theory is not fundamental, we can use it to study these violations of causation. Essentially, you get a superposition of causal sequences. How should we study consciousness? What is the solution to the self-referential problem? What are the latest research developments in the field of consciousness? Donald, I think there are several ways to study consciousness. One is a traditional method that has been used in the East and the West for thousands of years. People from various spiritual traditions have been doing meditation and breathing exercises to focus their attention on consciousness and discover all kinds of things about it from a first-person perspective. I think this is a great approach. On the other hand, science over the past 100 years has developed tools that allow us to address the question of consciousness from a strictly third-person perspective. We can study it by combining a first-person meditative perspective with a third-person scientific perspective. Spiritual traditions have gained very deep insights from thousands of years of meditation and observation of consciousness. Scientists should listen carefully to these insights. Spiritual traditions have not yet translated these insights into precise theories, but scientists know how to do so. Since Galileo, scientists have learned how to turn our intuitions and ideas into demonstrably precise mathematical theories. I believe we should encourage practical scientists and consciousness experts from various spiritual traditions to collaborate and share ideas. I think many spiritual traditions view words as indicators. Whatever the words say is not truth, they are just indicators, like the Tao Te Ching. I completely agree with the first sentence of the Tao Te Ching, Tao can be Tao, but it is not Tao. These words, or even scientific theories, are not truth, they are just indicators. But science has learned how to get subtle indicators. This is where scientific indicators are really powerful, they tell you where your limitations are. One of the problems with many spiritual traditions is that it's easy to become dogmatic, we have the truth and you don't. Our way is better than yours. We're right and you're wrong. We put too much faith in these indicators and get stuck in them. There is no way to extricate yourself from it. When spiritual traditions tell us that indicators are just indicators, we think our indicators are the right ones. Don't take metrics too seriously, go beyond metrics. Scientific indicators tell you where your limitations are. Like Einstein's theory of space and time, when we look at this theory it tells us about its limitations. For example, when you combine Einstein's theory of gravity with quantum field theory, it tells you that at less than 10 to 33 centimeters or 10 to 43 seconds, the concept of space-time makes no sense. The beauty of scientific indicators pointing to consciousness is that they avoid dogmatism. They are precise, give us precise insights, and tell us exactly the limits of those insights. There are still many unexplored areas of consciousness so that we don't become dogmatic. You'll find that this is a complicated answer to your question. We should draw on insights from spiritual traditions, and we should adopt new methods from science and combine them to create new indicators. Spiritual traditions will have difficulty because they like their indicators and may not want to abandon them. And scientists have to give up space and time, even though they don't want to. They don't like the idea that consciousness is fundamental. It's not easy on either side. But I think the next generation of scientists will do this, using insights from neuroscience, artificial intelligence, spiritual traditions, and mathematics to gain a scientific spirituality. It does not exclude the significance of the individual, but rather helps us understand what we are and helps us gain pointers to reality. Even if we understand, the reality of who you are will always transcend any scientific theory, any spiritual indicator. Underlying all the theories, all the indicators, are our theories, in some sense, getting closer to the truth about the real world, about consciousness, etc. Donald, once we get to a theoretical level beyond evolution, we don't have to worry about its limitations. Although evolution says that our senses do not reveal the truth, we may be able to let go of this once we enter a deeper framework. We don't have to believe in the implications of evolutionary theory. It depends on what our deeper theory is. But my own attitude is that no matter how far deeper theories lead us on the road to science, the unexplainable reality will be infinite. In other words, no matter how far it goes, science only scratches the surface. Even 1 billion years from now, if we have millions of new theories and ever deeper theories, we are only just getting started. This is unlimited job security for scientists. Scientists will never be unemployed because there will always be a deeper theory. In a sense, I would say that each of us is infinitely complex. Each of us is not an insignificant 150-pound piece of meat in space and time. We ourselves are infinitely complex. As stated in the Oracle of Delphi's inscription in front of the Temple of Apollo, the essence of science is the study of ourselves. The exploration of ourselves is infinite because we are infinitely complex. No scientific theory can fathom its depths. Yet, somehow, part of our nature drives us to explore what we really are through these different types of scientific theories, what spiritual traditions call forms. We use form to explore vast expanses of consciousness that we can never fully explore. Finally, for readers who want to comprehensively understand the research on computational models of consciousness and vision, can you give some suggestions, such as recommending some textbooks or review papers? Donald, there are many ways to do this type of research, depending on your interests and talents. If you have a talent for math and like physics, then I would recommend checking out what Nima Arkani-Hamed is working on. They discovered structures that transcend space and time. Physicists say space and time are not fundamental and have a deeper structure. What we need to study is figuring out what these structures are that transcend space and time, and how they connect to deeper ideas about consciousness. For those who want to read the specific paper, I have a paper called Objects of Consciousness that is available online for free. There is a mathematical model about consciousness in the paper. I am not saying that this mathematical model is correct, but it is accurate. You can search for my name and you'll find papers that I and other CO authors have written on mathematical models of consciousness. I also have a book called The Case Against Reality, Why Evolution Hid the Truth from Our Eyes, which will be released in Chinese soon. If you are interested in entering the entire field of consciousness research, this is a good book that can help you understand various issues and perspectives related to consciousness. I will use footnotes directly in the book to tell readers where to read the original paper. I recommend that students interested in the field of consciousness read this book. It is an introductory book, not an advanced one, and then read the papers listed in the book. You can read real scientific papers yourself, which would be a good starting point. Source: ChatGPT. The current understanding of consciousness remains a complex and controversial issue in science and philosophy. Building a complete and accurate mathematical model of consciousness is very difficult because there are still many uncertainties in the current understanding of the nature of consciousness. However, some researchers have tried to use mathematical methods to describe and simulate some consciousness-related phenomena. These models may be based on experimental results from neuroscience or on an understanding of mental processes and information processing. Here are some possible approaches. Integrated Information Theory, IIT. This is a theory proposed by Giulio Tonini that attempts to quantify the degree of consciousness of a system. IIT takes into account the degree of information integration and proposes a parameter called phi, which is considered a measure of the degree of awareness of the system. Neural network models. Some researchers use neural network models to simulate brain activity. These models may be based on connections and interactions between neurons, attempting to simulate the dynamic properties of neural networks. Computational models. Some computational models attempt to view mental processes as the result of information processing. These models may use mathematical and logical operations to describe processes of perception, thinking, and memory. It is worth noting that these current models are often only simplified descriptions of specific aspects of consciousness, and they fail to fully capture the richness and complexity of consciousness. The scientific understanding of consciousness is still in its infancy, and many issues still require more in-depth research. 16th. The Case Against Reality, Why Evolution Hid the Truth from Our Eyes. Source: blog. Author: Donald Huffman. What exactly is consciousness? Are perceptions real? Is there an objectively existing world? This time, you can only choose the red pill, a popular science book that is more brain-burning than The Matrix and comprehensively interrogates the truth about consciousness and reality. Cognitive scientist Hoffman uses rigorous logical argumentation, computer simulations, and scientific experiments to face the eternal and elusive philosophical mind-matter problem head-on. Despite centuries of scientific progress, the problem of consciousness remains unresolved. How electrochemical stimulation of brain neurons produces subjective experiences remains one of the universe's deepest mysteries. Cognitive scientist Donald Hoffman believes that this is not because humans are still waiting for new scientific discoveries or have reached the limits of their wisdom, but because our concept of reality is completely wrong. Once we grasp the nature of reality, the problem of consciousness can be solved. This book breaks your common sense and invites you to explore together the abstract nature of evolutionary theory, natural selection, genes, and mutation algorithms. The subjective nature of truth, game theory and the fittest theorem. The fictitious nature of physical causation, hologram theory and firewall theory. The universal nature of perceptual systems, user interfaces. The format nature of spatio-temporal content, actuarial report of fitness gain. Watch how Hoffman deduced step by step, discovering that the two pillars of science, quantum theory and evolutionary biology, join forces to resist our intuition. This book attempts to break the barriers of human knowledge from the most fundamental level, and may completely change the way you look at reality. Do our senses really accurately reflect the truth? Mainstream scientific theory believes that the information returned to us by the senses is objective reality. Cognitive scientist Donald Hoffman challenges this notion, arguing that while we should take our perceptions seriously, we should not assume that they are the truth itself. How could the world we see not be the objective reality? What good are the senses if they are not telling us the truth? In this eye-opening book, Hoffman grapples with these and related ramifications. Since Homo sapiens began to appear on the earth, the perception that can hide the truth and guide us to take useful actions has always had an advantage in natural selection. Therefore, our senses have been continuously modified in this direction, and we have survived and reproduced to this day. When we see a car speeding towards us, we know not to walk in front of it. When we see a piece of moldy bread, we know not to eat it. However, such an impression is not objective reality. Just like the folder icon on the computer screen is not what the computer file actually looks like, but is just a useful symbol, the things we see every day are just icons so that we can live safely and securely in the world. The arguments in the book have very important substantive implications, ranging from examining why fashion designers use clothing to create the illusion of a charming figure, studying how companies use color to arouse consumers' emotions, and even breaking down the fundamental belief that time and space are objective realities. This book uses rigorous scientific language and interlocking methodology to urge readers to raise essential questions about the world we take for granted. Celebrity recommendation. Woody Allen once said, "I hate reality, but where else can I get a good steak dinner?" Hoffman turned the joke completely on its head. What we are always after is a steak dinner. What we call reality is our best adaptive strategy for getting a steak meal. Enjoy it. Christopher W. Christopher A. Fuchs, Professor of Physics, University of Massachusetts Boston. Hoffman's radical theory will force us to think about reality from a completely different perspective. Be careful when reading, your perception of the world around you will collapse. Chris Anderson, TED President and Chief Curator. Do you think you know what this world is really like? Read this book and tell me. The author explains one by one the extreme weirdness hidden under our own experiences and assumptions. You will forget to breathe when you read it. David Eagleman, best-selling author of The Brain and Incognito. Want an eye-opener? In this intriguing, original, and captivating book, Hoffman guides us through uncharted territory, where cognitive science, fundamental physics, and evolutionary biology intersect. The nature of reality hangs in the balance here. Your view of the world, or should I say, your interface, will never be the same. Amanda Gifter, author of Trespassing on Einstein's Lawn. If you want to synchronize your understanding of reality with this world, then you must not miss this book. You will see many things that you never expected and beyond your imagination. This book stimulates you to think about yourself, others and the world. Young Jan Coenderink, author of Color for the Sciences. This book takes a new perspective, transcends our perception of reality, and explores the truth about ourselves. Hoffman leads us into a rabbit hole without hesitation, letting us understand that all reality is virtual, and the truth only belongs to you, the creator. Rudolf Tanzi, CO, author of Super Brain. A masterpiece of logic, reason, science, and mathematics. Please read this book carefully, and your understanding of reality will forever change, whether it is the reality of the universe or your own reality. Deepak Chopra, CO, author of Super Brain. Thought-provoking and courageous. Anyone who reads this book may find it hard to see the world the same way again. Hoffman asks us to rethink some of the most fundamental foundations of neurology and physics, and these may just be the what we most need to know in the future if we want to answer some of the big questions about the nature of reality. Anaka. Annika Harris, author of Conscious. Introduction: the world is conscious experience, and conscious experience is the world / Hong Ya Hung. Introduction: the nature of the mind / Xia Borang. Preface. Chapter 1: Mystery, the scalpel that divides consciousness. Chapter 2: Beauty, the charming song of genes. Chapter 3: Reality, the invisible sun is playing tricks. Chapter 4: Feeling, the fittest wins. Chapter 5: Illusory perception, bluffing on the computer desktop. Chapter 6: Gravity, the end of time and space. Chapter 7: Virtuality, expanding a holographic world. Chapter 8: Color decoration, mutation of interface. Chapter 9: A closer look, no matter in life or career, what you get is what you need. Chapter 10: Community, network of conscious subjects. Appendix: Accuracy, eligibility to make a mistake. Source: ChatGPT. Unreal Reality, How Evolution Hidden the Truth and Shaped Our Perception of Space and Time is a book by Donald D. Hoffman. In this book, Hoffman, a cognitive psychologist, presents a fascinating and conventional theory of how evolution shapes our perception of reality. One of the book's main arguments is that our perceptual systems do not directly reflect the real world but have been shaped by evolution to improve our chances of survival and reproduction. Hoffman used a metaphor, such as the icons on the computer desktop. These icons are only used to facilitate our operation of the computer and do not directly correspond to the binary operations of the computer. He believes that our perceptual system evolved to provide us with a useful interface rather than a direct display of the real world. This theory challenges the way we perceive time, space, matter, and consciousness, and attempts to explain some phenomena in psychology and neuroscience. Although this view has generated discussion and debate in academic circles, it has also been questioned by many professionals. If you are interested in this topic, I recommend reading this book by Hoffman to gain a deeper understanding of his theories and arguments. Hoffman's ideas challenge our intuitions about reality and perception and prompt a rethinking of these issues. 17th. Introduction to Unreal Reality. Is the physical world we are familiar with actually the product of our conscious experience? Source: Critical Reviews. The world is conscious experience, and conscious experience is the world. When you see a flower, you believe there is a flower in front of you. The question is, when you close your eyes, is the flower still there? Everyone has heard the story of Wang Yangming's flower in the mountain. A tree blooms in the mountains. If no one sees the flower, does the flower exist at this time? In traditional records, Wang Yangming replied, "When you didn't look at this flower died with you. Now that you look at this flower, the color of this flower becomes clear for a moment, and you know that this flower is not in your heart." Wang Yangming said this flower is not outside your heart has many different interpretations. The core question is there an objective world outside your mind? The so-called objective world refers to the physical world that exists independently of consciousness or mind. Hoffman's book aims to answer this question. His conclusion is that the world is not outside your mind, and everything in the world only exists because someone observes it. The flower of the mountain does not exist when no one is looking at it. The flower in front of you does not exist when you close your eyes. As soon as you open your eyes, it exists again. Such an idea may seem counterintuitive. Normally we think of the external world as objective and independent of our sensory experience. Things in the world exist by themselves, without our observation or experience. What Hoffman wants to deal with is one of the core issues of philosophy, the mind-body problem. His view is closer to subjective idealism, a bit like the British empiricist philosopher George Berkeley, 1685–1753, statement that existence is perception. However, Hoffman sometimes said that his ideas were not idealistic. Idealism advocates that personal feelings, experience, consciousness, mind, etc. are the basis for the existence of all things and the most fundamental existence. Physical things are derived from consciousness or mind. Hoffman believes that there are no physical things in the world at all. Everything is a consciousness and non-material, so there are no physical things derived from consciousness or the mind. Why would Hoffman make such a strange statement? There are two motivations behind his discussion of this issue. One is the hard problem of consciousness. Today's mainstream academic circles mostly believe that consciousness is produced by the brain and that consciousness is a physical phenomenon. However, since the 1980s, consciousness has become a hot issue in the scientific community. For nearly 40 years, no one has been able to come up with a satisfactory answer. Physicalism, which is the modern version of materialism, is popular in mainstream academic circles. Physicalism advocates that the most fundamental existence in the world is elementary particles, which are substances. There is nothing in reality other than physical things. Consciousness and mind are functions of the brain. The action of the brain's nervous system produces conscious experience. When you see an apple, light waves hit your retina, generate a signal, and then are transmitted to the visual area of the brain, thus producing the visual experience of a red apple. The problem is that no one can answer how the neural networks in the brain work to produce the variety of sensory experiences. Brain science can only tell you the assessment of beauty, but cannot tell you how the brain generates aesthetic experience. This difficult problem made Hoffman seriously think about whether the theory of physics is wrong. The most fundamental existence of the world is not matter. The second is the impact of quantum physics. Everyone is familiar with the double-slit experiment. Microscopic particles such as photons and electrons will interfere with each other during the experiment. If you hit one photon at a time, it should pass through one of the slits. It stands to reason that there would be no interference. But experiments show that even if only one photon is hit at a time, interference will still occur. This means that a photon will pass through both slits at the same time. After the photon is shot out, it advances in the form of a wave, and it is possible for a photon to pass through two slits at the same time. If we use a detection device to measure the path of the photon before it passes through the slit, the photon behaves like a particle and the interference disappears. Physicist John A. Wheeler conducted an experiment to detect which path the photon took after it passed through the double slits. It turns out that the photons seem to go back in time and take another path in the form of particles, and the interference phenomenon disappears. This experiment seems to illustrate that observation affects the behavior of particles. Everyone is familiar with Erwin Schrödinger's cat. Schrödinger conducted a thought experiment, asking you to answer whether a cat in a closed box is alive or dead. There is a chance that a cat will die from eating a poisonous fish, and there is a chance that the cat will survive without eating the poison. Without opening the box, is the cat dead or alive? Schrödinger's answer is both dead and alive, both are true. But when you open the box, the cat is either dead or alive. Observation will make the difference between a cat's survival and death. So some people joke that curiosity will kill a cat. Here I only give the above two examples to illustrate the importance of observation in quantum mechanics. In this book, Hoffman discusses in great detail the role and importance of observation in quantum mechanics. What he wants to argue is that the real world is actually a product of observation. Somewhat similar to Wheeler's participatory universe, it is believed that the universe we experience is created by our observations and is not an objectively independent universe. If physical theory is wrong, what about Hoffman's claims? If there is no physical world independent of conscious experience, and the physical world we are familiar with is a product of our consciousness, then conscious experience cannot be the result of physical action. Vision is not produced by the brain, and all sensory experiences, emotions, thoughts, and wills are not produced by the brain. Instead, consciousness produces the brain. Consciousness creates the world, and the world exists because of our sensory perceptions. Therefore, for Hoffman, brain science has gone in the wrong direction. Instead of looking for the cranial neural basis of consciousness, we should look for the cranial nervous system's conscious basis. Consciousness is the most fundamental existence of the world, reality. The existence and operation of all things must be explained by consciousness. It is wrong for physics to believe that particles are the most fundamental existence. No wonder science cannot find how consciousness occurs, because consciousness is the most fundamental existence, and everything is explained by it. Hoffman believes that the hypothesis that consciousness is the fundamental existence is supported by quantum mechanics, because quantum mechanics supports observation, consciousness, to produce quantum collapse, from a pile of superpositions of possible worlds to the collapse of what we experience. The real world. So the world is a product of consciousness. Next we will look at how Hoffman established his theory step by step. First, he discusses from the theory of evolution that the world we know is not the world itself. He believes that the theory of evolution is about the survival of the fittest, fitness, not the survival of the truth. This is his FBT, fitness beats truth, theory. The perceptual system evolved through evolution pursues fitness for survival rather than truth. He said that we need to abandon the assumption that the reality we see is the reality itself. He wants to abandon metaphysical realism, that is, the claim that conscious experience correctly describes things in themselves. Sensory perception creates a personal world, personal reality. There is no public world. Hoffman does not believe that there are physical things that exist beyond our perception, nor that there is a world hiding behind our perception that we cannot understand and cannot touch. His theory therefore differs from Kant's realism. Kant maintained that physical science can only explain our empirical world, and that the world we know comes from 12 innate categories, concepts. As for things themselves, they are beyond the scope of our concepts. Although we cannot understand the things themselves do exist. This is what Hoffman objects to. The world exists, but this world is constructed by consciousness, because consciousness is the most fundamental existence. The physical theory that Hoffman opposed is that the world exists, and this world is constructed of elementary particles, because elementary particles are the most fundamental existence. In order to distinguish it from the realism of physical theory, Hoffman called his own theory conscious realism. The world is made up of conscious agents. Agent means agent or actor. Here, agent refers to something that has sensory perception, can perceive the outside world, and has the ability to act. By analogy with the names of basic particles such as photons, electrons, and protons, I translated them as consciousness particles. Consciousness is the basic element of the world. Human beings are composite consciousnesses, made up of many other simpler consciousnesses. Hoffman used split brain research to illustrate that a bunch of idions can be combined into composite idions. Roger Sperry discovered that severing the corpus callosum, which connects the left and right halves of the brain, can not only effectively treat epilepsy, but also split the patient's original self into two independent selves. For Hoffman, since two selves can be combined into one self, many consciousnesses can also be combined into one consciousness. Consciousness has consciousness. What does it perceive? Because the world is composed of consciousness particles, the perceived objects of consciousness particles are also consciousness particles. However, consciousnesses cannot directly perceive other consciousnesses themselves, but can only perceive the icons of other consciousnesses. When we perceive the external world, such as flowers, trees, rocks, dogs, people, cars, etc., these things are not things in the world itself, but useful icons. What is an icon? Hoffman uses the analogy of a desktop on a computer screen. On the desktop of your computer are some icons, which may represent a file. You can open it or throw it in the trash. The icons on the desktop are the interface for you to use your computer. These icons simplify and make your work more efficient. You don't have to know how a computer works internally. Just like the result of evolution only gives you the fittest but not the true one, we do not need to perceive the world itself, nor do we need to assume that there is something beyond the scope of our understanding, or the real world. A consciousness perceives the icons of other consciousnesses, but cannot directly perceive other consciousnesses. This theory Hoffman calls multisensory user interface, MUI, theory. The conscious perception experience of a consciousness is the MUI between the consciousness and the external world. In other words, conscious experience is what the user interface can give you. When you experience a stone, it does not mean that there is something called a stone in the objective world. You just experience the stone icon, which is the icon of the stone in the user interface. The objects of experience are not public. In other words, when you and I see a glass of water, we do not see the same glass of water. Everyone's MUI is private and there is no public thing. In other words, conscious experience is private, I cannot experience your pain, and vice versa. Everyone lives in his own private world of experience. Finally, we summarize Hoffman's theory in everyday language. The universe is like a supercomputer, and time and space are its desktop. This desktop is a three-dimensional desktop, which is different from the two-dimensional desktop of ordinary computers. All things in the universe are like icons in this three-dimensional desktop. Your daily routine consists of interacting with these icons. What icons represent and what they can do are the result of evolution. These icons make you suitable for survival and reproduction of the next generation. As for what the cosmic supercomputer is and how it works, we don't need to know, and we won't know. We only live in the world of icons. Just like how we use computers every day and use icons efficiently without knowing how to throw a file icon into the trash, the chips in the computer operate. So the world we know is not what reality itself looks like. This reminds me of Liu Zhiyuan's words, the four directions above and below are called the universe, and the movement from ancient times to the present is called the universe. The universe is my heart, and my heart is the universe. The universe is my conscious experience in the three-dimensional interface of space and time, and my conscious experience is the entire world. Could this lead to solipsism? Am I alone in my own private world of experience? Perhaps Hoffman would say that his theory is similar to G.W. Leibniz's monadology and does not have the problem of solitary egoism. What this means will be discussed in another introduction. 18th. How accurate are your eyes? Source: Daily Headlines. If you look up close, it's Einstein. But if you take off your glasses and look at it from a distance, what? It's Marilyn Monroe? Is it static or moving? Looking at these two face photos, the only difference is the contrast, but they look like a man and a woman. This is because the contrast between the eyes, mouth, and the rest of a woman's face is greater than the contrast between different parts of a man's face. Still picture plus grid equals animation. If you see this dancer turning clockwise, it means you are using the right side of your brain. If it turns counterclockwise, it means you are using the left side of your brain. It's amazing, how can eggs move to high places? Watch the black dot body move back and forth. Can you see four faces? You can see several avatars in the picture at a glance. There is a person inside. Can you understand this strange picture? Can you see the bear? It is said that there are 7 horses in this picture. Where is the lion? It is said that someone who can see 9 faces has an IQ of 180. Conclusion: to see a world in a wild flower, and a Bodhi in a leaf.